This video is audio described for people who are blind or are visually impaired. Students are working in small groups in a classroom as an instructor walks around.
So that first problem situation is something about salaries for employees at a company. I imagine everybody likes to get a paycheck.
The projection on the board states, October 4th, 2016. We will have a class handout for a substitute lesson on Tuesday, October 4th. I'll have details to share about the special project at our September 29th class meeting.
And I like it when you get a raise. It's a good thing from one year to the next, get paid a little bit more than before. So we're going to look at the situation with these three employees here and see what the change in their salaries tells you. With that, I'm just going to let you dive into problem situation 1 and start talking that over with your groups.
A group of 4 students is working on worksheets together.
Yeah, okay, so then it'll be 4,000? No, it'll just be 4,000. Oh, got it. Okay.
Yeah, right.
Yeah.
Well, that is $800.
Yeah, that is quite a bit, 800.
So it'd be $4,000.
4,000.
Yeah.
Yeah.
So that'd be a fair raise because it's 10%.
Find a difference.
We're supposed to do number 2 as well. I don't know, are we? That's what I'm asking. Just problem 1. Okay.
Question 3 on the worksheet asks, based on your discussion of Maria's situation, what do you think would be a fair raise for Maria to receive? The student writes in their answer of, a $40,000 raise would be fair for Maria. This is 10% of her previous salary.
Is it just problem 1?
I don't know. I said this.
But then we have
Just going too quick.
The students move to the next page of their worksheets and begin reading.
Read the first one.
Table of motion.
Shows the share prices for 3 stocks over the course of a year. Ah. Okay, rank from best to worst the 2013 performance of the above stocks.
from 350 to 5.
The instructor comes over to the group.
Are you really done with 1?
Yeah.
The students return to the previous page of their worksheet packet.
I'm
What did you find out here? What mathematical thing did you do in question 1?
Well, we had to figure out why she felt that it was an unfair raise compared to her coworkers.
Before you even got to that.
Right.
It's numbers in number 1. What did you do to calculate
Found the
those?
difference.
The dollar amount of each person's raise.
Yeah.
Right. You found the difference. What mathematical operation is that?
Subtraction.
Subtraction.
Divide
So subtraction is one way to compare
difference
2
by
numbers.
the
Yep.
remaining price. Find
And
10%.
So then,
Maria's getting the biggest raise, but she's still unhappy.
yeah, but she's still yeah.
And why is she
Yeah.
unhappy?
Because she only got an 8% raise, whereas the other 2 got a 10% raise.
Roughly.
Yeah.
Okay. How did you figure the 8 and 10%?
Well, Ethan. Well, we just took the difference in the raise, and then we just subtracted or divided it from last year's salary to find how much of an increase it was.
The difference in salaries divided by
The 2015 salary.
the original salary.
The worksheet shows a table with various 2015 and 2016 salaries.
And that gave a percent raise from one year to the next.
Okay. That sounds good. So what I'm going to ask your group, you've got a nice result there. Can you think of a different way to come to the same conclusion?
A different way to
A
like,
different way that you can, is there a different way that you could compare salaries from one employee to another? Or to compare the raises they got? Instead of just looking at the percentage change. I'm just going to leave that as a challenge for a couple minutes to think
Yeah.
about.
The instructor walks away from the group.
so A different way to get included, like as in percentage-wise?
If we're to look at this in a way that wasn't percentage, like, that might be what he's asking.
Right, yeah. So I'm just trying to think like if it's more like of a fraction type thing that he's trying to get at. So like,
Maybe.
The raise.
Like, the obvious statement is that she's making 10,000 more than Peter here.
Right, like 10,000 more
still
than this
getting-
person and 15,000 more than this person.
Yeah, and she's still getting roughly the same raise as a person who's making $10,000 less.
Right.
So if we were to mathematically word that in a way that did not use a percentage, how would we go about that?
That's a good question.
I knew what the hard was.
Okay, I'm gonna read this little absolute change thing right here.
The student reads a portion of the worksheet that references absolute change.
Absolute change, total amount of change between two numbers.
You had a higher percent.
Shoot.
Really, when it decreases, it's negative.
Right.
Looks like she made more, but really she didn't.
I'm really trying to brainstorm here.
I know, me too.
Once the colleagues raises. Okay. Wages too low compared to the others.
Raise was too low.
Would it differ if we have a larger percentage?
I just don't know what he's looking for.
Yeah, you divide 350 by 559.
The students continue to look at the table showing the various salaries. Maria has a 2015 salary of $40,000 and a 2016 salary of $43,200. Peter has a 2015 salary of $30,000 and a 2016 salary of $33,000. Lawrence has a 2015 salary of $25,000 and a 2016 salary of $27,500.
See, we just said that. I mean, like, if you have literally $10,000 more a year than this person and $15,000 more a year than this person, it's kind of like, it's kind of funny because she's complaining even though they got, they got a bigger raise, but I mean, they're making less money. So it's like, it doesn't really, it's like, oh.
No, she's just that one person at work.
That one
no
girl,
one
that
likes.
one woman. So like, now I'm just trying to figure out. I keep thinking in fractions, but I don't know how to put this into a fraction. Like,
So how'd you go about finding that percentage, Ethan?
that percentage was dollar amount, or well, yeah,
So like, if you got a $3,200 raise, you just divided it by the 40,000.
40,000.
Profits compare, use this value to compare profits earned in the stock with the largest percentage.
Okay, number
Bring
4.
stock with the
Guys, got me stumped. I don't know. There's another way to figure it out.
So it's pretty much saying like whatever number you gave us, like which company.
Seems like you've all moved on to problem situation 2, so it'd be good if we can talk through. Can we have quiet?
The instructor stands in the center of the room to get the students' attention.
Let's talk through the first problem situation and see a couple of the different strategies that we saw around the groups here. Sounded like people got through that pretty efficiently, but I'd like you to hear some of the different ways that groups approach the same problem. First of all, with question 1,
The worksheet is projected onto a screen in the classroom.
let's pick on you guys over here. How did you find the amount of the raise for each employee?
You find the difference between the 2016 salary and the 2015 salary?
So we're just finding the difference. I'm going to just abbreviate this as the new salary minus the old salary, so I don't get my fingers tied up in the 2015s and 2016s.
The instructor enters the difference between the 2015 and 2016 salaries for each employee to answer question number 1.
The difference for Maria was $3,200, and for Peter,
3,000,
even $3,000, and for Lawrence,
2,500.
$2,500. So these employees are doing pretty well. They're all getting substantial raises for the year here, if life were only that good for all of us. So question 2 then raises a question. Well, there's a little note in there below that we have this absolute change that we found. When we subtract two numbers, we're finding what we call the absolute change mathematically. Just straight up subtract two numbers. What's the difference between these two? There was an absolute change of $3,200 for Maria, $3,000 for Peter, and $2,500 for Lawrence. So in question 2, you get this little issue about Maria's unhappy. She got the biggest raise, but she's unhappy here. So Brandon, Ethan, Nami, Crystal, what can you say about why Maria's unhappy?
Well, Maria had received a 8% raise compared to her colleagues, which both received a relative 10% raise. And even though she had received that $3,200, it was just not good enough for her, I guess. But, you know, Maria. So that's what we calculated, that she received a lower percentage compared
To her coworkers.
to her coworkers.
So Maria got an 8% raise while the two guys both received 10% raises. And how did you actually calculate that percentage raise or percentage increase?
Percentage of increase?
Oh, yeah, we took the difference between their old and new
Okay.
salaries and then just divided it by their old salary to find the percent increase.
The instructor answers question number 2 on the board with, Maria received an 8% raise, while the two guys both got 10% raises. He also writes, percentage increase equals the difference between the old and new salaries divided by the old salary.
The difference between old and new, and divided that by which one?
The old.
By the old salary.
2015 salary.
And if I can just shorten that down a little bit, you're taking the new minus the old, and you're dividing by the old value. And that gives you numbers like 0.08 for Maria, 0.10 for the other two. So that's a nice approach, and it gives a mathematical way to compare those raises, even though they were coming off different dollar values. The percentage change is talking about the difference, the increase relative to what it was to begin with. So that was one approach. Jashan's group, you had a different approach to this.
You should talk to Jay Sean about it.
You're the spokesperson.
So we just divided the 2016 salary over the 2015 salary, and you just see how much they made, like total.
Simply dividing the new one by the old one produces numbers like,
Like for Maria, she got 108% more.
The instructor writes on a whiteboard that the 2016 salary divided by the 2015 salary is equivalent to 43,200 divided by 40,000, which equals 1.08, or 108%. This equation is also represented as the new salary divided by the old salary.
so that came out to 1.08.
Yeah.
I know I saw that was the first number you had. And you're interpreting that as 108%.
And you
But
just
that's not a raise.
So you just subtract 100 from it, you get the 8%.
This is really 100% plus 8%. That 8% is the raise, which agrees with our first group over here. What is the 100%?
just the number,
The
like
initial.
40,000 divided by 40,000.
It's the initial 40,000. If we didn't have this raise, it would have been 40,000 over 40,000, would have just been the 1. So essentially, we've always got that 1 sitting there when we divide a new value by an old value. And the growth is what's coming above 1. So we have the original plus the raise. That's Kylie.
So you just said that if we divided an old value or a new value by an old value, the 1 would be there, but that's not true if the new value is less than the old value.
That's a very good observation. If the new value is smaller, we end up getting a number that's less than 1.
Right. So the 1 is representing, so the 108% is what percent is this value of the last value. And since 40,000 would be 100%, 108%, the 8% represents the increase.
Right, but we could still compare to 100%.
Yeah, exactly.
We'll just be under that, so there would have been a decrease for the part that we're under 100%. We'll get an opportunity to struggle with that a little bit later. So we'll hold off on that decrease part for a moment. So this was the case for Maria. What did that ratio turn out for Peter?
110%.
101.1, which is 110%, which is talking about a 10% increase from the original.
The teacher writes on the board, relative change is a division or percentage which equals new minus old, divided by old. This is also represented as absolute change divided by the original.
Again, 100% was the original value, so the 10% is the increase part. And Lawrence
Same.
was the same. I'm spelling something wrong there. So what do you think about that method?
It's a good one.
It works, which is nice. Our two methods produce the same result, which is also really nice to know that we're getting the same thing even though we're thinking about it a different way. Which method do you like better? Julia, you like the first method? Kylie?
This method is effective because that's one less step that you have to do.
That's one way to look at it. There's one division. We didn't even have to bother with the subtraction problem, except really we did subtract the 100% off later, although subtracting the 1 is a really simple calculation, as opposed to subtracting the raw numbers may not be so easy.
Especially if the numbers are bigger or more complex.
Sure. As we get more complicated numbers and more digits or just uglier things, it may be nice to work with this method. But the point is you get a choice. Do we have yet a different method that we don't have represented with these two ideas? Okay, everybody did one of those two, I think. All right. Any other thoughts about this? We go on with problem situation 2. What did we end up learning in our mathematical ideas here from these couple problem situations? Absolute change is a subtraction.
Old value equals a dollar.
Just new minus old is a simple way to write that.
Yep.
Relative change
Is division,
is a division.
and it is new, well, the old value is the denominator, I suppose.
It's equal to what? How did we find it?
New divided by old, right? No?
And then divided by old.
The,
New minus old
Divided by old.
okay. We took
We got
that
it together.
absolute change and divided by the old value. new minus old. Or you could look at it as the absolute divided by the original. If you take the absolute change and compare it to the original value, you get the relative change. Any other thoughts on important ideas in that lesson? Those two really nail it. If we can keep those straight, decide when to subtract, when to divide, those are going to tell us slightly different things, give us a different perspective of the change, but using those effectively will be good mathematics for us. All right. So I guess we'll close that off here.